a responsibility, because we're a team here. If I forget to hit the record button during the lesson, just give me a reminder in the chat. I would appreciate it. So if we start the second part of the class after the break and I don't record, hey John, you got to record, okay? And I'll record it. So this way we get a nice, good quality production. So you're like the directors, okay? So anyway, what is a significant digit? Yeah, exactly. Trust me, I'm not here because I'm like, honestly, I want to be here. It's hilarious. I hope you have a good time this semester. Okay, so I'm 5'10", but I'm gonna say that I'm 5'11" just because it's nicer. So I'm 71 inches tall. And then I asked my friend, hey, how tall are you? And they're like, oh, I'm 6 feet tall. So 6 feet tall, but then they go off on the rails there and they don't say they're 72 inches tall. They say they're 72.165. Okay? So then I asked my friend, hey, how tall are we together? So let's add our heights together. So when we add our heights together, what should the answer be? Is 143 a good answer, or do I put the decimal stuff? Do you think I should put the decimal stuff? Yes or no? Okay. So I think the better answer is no. The reason is my height compared to my friends is not as accurate. So my height as a number is less reliable or accurate than my friends. So this is a way of quantifying how accurate a measurement is, and therefore gives us rules in how we use the measurement. So over here, we need to figure out how to measure accuracy, and that's done by number of significant digits. So if a number is not 0, it's significant. It is significant. So this one and this one are really, really easy because there's no zeros. And this one here too, there's no zeros. The issue with significant digits is that 0 sometimes is significant and sometimes is not significant. And if you grab a textbook, look online, and you're like, okay, well, can you explain it to me, whatever, sometimes you get these ridiculous one-page flowcharts where they try to explain it. I can't do that. So what I do instead is, it's like I'm learning a language, like an alphabet or something. So what I do is, I set up a bunch of examples, and it's like building blocks. So you need to figure out, you need to work your way down this list and understand why these numbers are so, and you can read the reasoning on the right for that purpose. So I'm going to flag a couple of numbers here, and we'll talk about them. This 50 here has one significant digit. The reason it has one significant digit is because the 0 at the end is only there because it's a big number. I mean big number relative to 1. Like, for example, if I said to you, how old is this fossil? Let's say you're an archaeologist, and you're like, oh, that fossil's 5,000 years old. Is it exactly 5,000 years old? Probably not. But you know that your measurement is accurate to at least the nearest thousands of years. So you know that that 5 is good, but those zeros are only there because it's a large number. So that's why numbers that have zeros at the end that are bigger than 1 have only the number in front counts. The numbers that are not 0 in front count. So a number like 450 here, this 0 is also just a place value. It's just telling you the number's big. That's why it's 2 significant digits. Now you might say to yourself, wait a second, John. What if I said to you, hey, how old is that professor? And they're exactly 50 years old. Like, that 0 is not like a gray area. They are 50. They're not 51. They're not 49. They are 50. The way that you emphasize that that 0 is significant is you put a dot. See that dot there? That tells somebody that they are 50 years old. Exactly. And without reliability there, it's all there. See, 2 significant digits. So when the numbers are big, usually the zeros are there to tell you that it's big. Let's talk about sandwiches. So I had a sub for lunch, so this is kind of ironic. But anyway, there. That's a sandwich. See? See how the zero is like a sandwich? Anytime a zero is sandwiched in between two numbers that are significant, that are not zero, then it is also significant. So that's why it's 3. So that takes care of numbers that are bigger than 1. If you have numbers that are smaller than 1, it's the other way around. So these zeros here that I'm showing you, they're only there to tell you that the number is really, really small compared to 1. But then any numbers after that are significant. So the answer that you should be most interested in is this one, 0.00707. This is 3 digits because this 0 here is not a place value. It's not there to tell you the number is small. It's actually just sandwiched in between two non-zero significant digits. If you're wondering, you see how I'm drawing all of these things on this file? I'm going to draw a bunch of stuff or whatever. I will share this file with all the annotations on Blackboard at the end of class. So when we finish class, I'll convert this to a PDF and I'll put it on Blackboard. In addition, I will also post the solutions typed up nice and pretty, my formal solutions with sentences. You're welcome. I will post those solutions as well on Blackboard. So you're getting 3 things from me, guys. You're getting the recording. You're welcome. The recording, my handwritten notes or stylus written notes, whatever, and also beautifully typed up solutions. So if you want to see it there, you just want to watch or whatever, it's all good. Anyway, I don't like this whole decimal business. It kind of pisses me off. I like this. This is scientific notation. You cannot screw this up in terms of significant digits. In scientific notation, whatever numbers you put here, whatever digits you put, even if they're 0, they're all significant. So, see, 1 digit, 1 digit, 2 digits, 2 digits, 2 digits, 2 digits, 3 digits, 3. No confusion. And the beautiful thing is, look at the explanation. The explanation is copied and pasted because it's the same thing every time. All digits in scientific notation are significant. You can't screw it up, okay? So now we are going to take a break shortly, but it's very important that I cover a few examples so that at least I can program into your head how the lesson is going to evolve. So let's do some really easy questions. Question 1. So if you don't have this file printed, don't worry. Just grab a notepad and start writing on your notepad. For future classes, either print this file or some students might load it on their iPad. If they have a tablet or something, they use their stylus and they can draw on it on the side. Find a way that works for you. But if you don't want to print or you don't have access to all that stuff, whatever, all you need is your computer screen. And just grab a sheet of paper like me and just write it on a sheet of paper. It's all good. So let's get to business here. State the accuracy of this number. So I'm going to write a little template here. It is accurate to blank. So that's how you're going to answer this type of question. I don't care if you use a sentence, because on the MyLab, you just have to tell the number. You don't have to like give me a story. So how many significant digits is this one? Correct. 1. Now, so it's going to be 1 digit because these zeros here, yeah. Thank you, Ravina. Yeah. So these, like, if you want it, not for your question, Ravina, but just in general, if there was a dot here, then it would be 3. But there's no dot. There's no decimal. So I'm going to do the following. I'm just going to copy and paste this text box. Whoops. That's not a text box. It's not good. And I just want you to do examples 2 to 5. You got 20 seconds. Okay, example 2. What do you think for example 2? Yeah, 2. 2 for 2. Literally 2 for 2. That's good. And what about example 3? Honestly, isn't this hilarious? It's like I'm the laziest teacher ever. You're doing all the work. But yeah, it's as easy as 1, 2, 3. Okay, this one's tricky. Do you want to go for 4? 4 for 4? Let's get some more lulls. 4 for 4? Yeah, it's 4 digits. See, this 0 here is only it's actually significant. If you're like, hey buddy, I don't understand. You said zeros at the end or whatever, right? But let's talk about this. If this 0, it's there for a reason. If I write 14.1 for computational reasons, it's the same as 14.10. But that 0 there is there. It's deliberate. Why wouldn't it be there? You have to think of it almost psychologically. Like it's there for a reason. Someone put it there because they intended it to be accurate to the nearest hundredth. Number 5. Very good. You guys are catching on very quick. I like that. Okay, so let's go to number 6. And now we're gonna do these 3 questions, then we'll take a break because we're almost on pace for being back on track again. Oh, yes, the 3 significant digits. The answer is 19.6. So if you're not sure why that's the case, you want 3 significant digits. So these guys that I'm underlining have to stay. But these guys here, we got to toss them away. So if you want to toss them away, that's bigger than 5. So you're going to round this up to a 6. Okay. This is 49.3. Very good work. Because you want to get rid of the 5. You gotta trim it off of the right always. This one's trickier. And I think Ravindra nailed this one. Good job on that. Yeah, it's 20. So for this one, I want you to think of the following picture. So I have to open up a Chrome window for a second, okay? See this picture here? You see this picture right here that I'm circling with my mouse? That's what I think of when I see situations like this. When I see this, okay? Because it's 19.9, and I think about when I'm driving, what's the next number that's going to show up on my odometer? It's going to be 20.0. It's like when you go to the new millennium, like when you hit the year 2000 or something. So yeah. Anyway, it's a nice analogy for that kind of stuff. So there were a lot of questions in the beginning. So hopefully I'm not going to saturate your brain too much. It's probably worthy of a nice little break now. So my clock says 1:53. So why don't we meet back at like 2 o'clock or 2:05? Okay. Now I'm not like I'm not that OCD with the time. You're welcome. But yeah, I'm gonna go make a tea because I can't talk for 3 hours straight anyway. So I'll see you guys at 2:05. Okay. So I'm just gonna say here I'm offline. Oops. Okay, see you in a bit. Skills. Thank you. Okay. So I'm going to be using a lot of. I find that the thing that I use to draw this stylus thing on Blackboard Collaborate, it's very slow and sluggish. So I'm using text boxes with Microsoft equations. So if you're wondering what I'm doing here is I'm hitting a command up in the actual PowerPoint menu, which is called Insert Equation. But I'm too lazy to type that, and I'm using a keyboard shortcut. So 1 over 32. So we're going to convert that into a decimal accurate to 3 significant digits. So the first thing you want to do here is make it a decimal, which is that. Yeah, I think you're on the right track there, Shazad. You want 3 sig figs. So is it 312 or 313? So the answer is 313 because you're rounding the 5 up. The 5 is going to round the 2 up to a 3. Okay. So the reason that this is the answer is because these zeros here are not significant. Those zeros are there just to tell you the number is small. They're place values. Like if I give you this, check out this number here, 313. See that number? That's 3 significant digits. You see all these zeros here? Whoops, all of these zeros at the end? Those zeros are only there to tell you the number is really big. And these zeros here are just here to tell you the number is small. That's all. They're not special. They are place values. So let's apply the same logic to the next question. Can you guys hear me? Yeah, Joseph, maybe just go in and out of the session, Joseph. Just come back in again, okay? Hilarious. Hilarious. Okie dokie. Can you hear me now? Yeah, let's make that 9/7. Good. Thank you, Joseph. So 9/7 as a decimal, it goes on forever. But it essentially is going to repeat this pattern over and over again. I don't care how many times you write it. Let's just write let's write 5 digits, 6 digits, okay? You can put a bar on top to say that it repeats. You can put a bar on top of that, but that's too much typing. To get to 3 significant digits, it's 1.29 because this 5 here is going to round the 8 up to a 9. So if this is a 4, well, that's okay. That's okay because I'm not going to ask you to do a lot of fraction calculations. Most questions, Victor, that involve fractions, my first step is to get rid of the fractions. And you're going to see more formulas. Okay, so no problem. Not a problem at all. Okay. By the way, you're very welcome. See this 1 and 2/7 business? Proper fractions? I couldn't care less about proper fractions. As an engineer, I rarely use them. The only time I ever see a proper fraction, you know where it is? Home Depot, when I want to go buy wood to make some stuff. Home hardware. Aiden, I'm not sure what's going on with your computer, but the lessons are being recorded. So yeah. Aiden, I'm not sure what's going on with your computer there, man, but I think Someone's saying you should try to zoom in. Yeah, you need to zoom in then. You need to zoom in on the content. So there's a button somewhere on the screen. Okay. Thanks, Kiara. Okay, you know what we'll do? I'm going to continue the lesson. Aiden, the lesson's being recorded, so you can see the recording of it after. We're not doing a crazy amount of questions. But when I finish the next break, you and I will sort it out during the break, okay? So that's the best I can give you right now. I don't know why it's not happening, but you're welcome. Your classmates seem to say something about zooming in. Because I'm not a student, I don't have the same angle as you. You're a champ, Kiara. Thank you. Hook them up. Because I am at a loss right now for that one. But that's why it's the first day. We help each other out. Tech support, yes. I'm not wearing one of those nerdy shirts. Okay. All right, so we're going to sort it out just during the next break, okay? So Aiden, just hold off if you don't mind for a little bit. Okay, so let's take a look at the next example. Oh, Aiden, you know what you can do? Grab the workbook off of Blackboard and use the workbook and use my voice to do the questions. At least you can follow along that way, okay? In the meantime. Because the workbook is very self-explanatory, and I'll say the answers out loud as I'm writing the final answers as we do the harder questions. You're welcome. The topics today are very easy, so you're not like it's not a disaster. We'll sort it out by the break. Okay, so the next question is you want to estimate the area of a room, and they're giving you the dimensions of 475 feet by 862 feet. And you want to find an estimate and also compare it to the exact answer. So let's get the exact first. What's the area of a rectangle in the chat? Anybody? Thank you. So it's length times width. So 475 feet times 862 feet. Give me a number. Who's got a number on that? Yeah, 409, 450 square feet. Okay, by the way, anybody coming here from elsewhere in the world where they have points instead of commas, you know, like dots for thousands, make sure that you keep it as the commas, yeah. And in worst case scenario, if you're writing an answer using the Blackboard, using the MyLab for the quizzes, don't put any funny stuff in the numbers. So if this is an answer on MyLab, just type that in, okay? But the numbers aren't going to get that big, I think. So that's the exact answer. Oops. Now let's do the approximate answer. So 475, it says here keep one significant digit. So what is 475 if you round it to an accuracy of one significant digit? 500. Good. Don't round the answer. Don't round the final answer. Just round the digits that you're with. 862 is closest to 900. And then multiply those. So the exercise is this. I'm going to get back to a comment that David mentioned. David, don't round the answer from the previous question. Don't round this. Don't touch that. The idea is that, what if you didn't have this? What if you were in a meeting and you had to figure out how much supplies to order, okay? So let's say you did this. You're in a meeting and someone's like, hey, how many square feet is it roughly? You need a quick thing. You need to figure out a number in less than 5 seconds. If you can do this thing in blue in your head, then this stuff here approximately, you don't need it because you're good enough to do it in your head. But I don't know about you. I'm either not good enough or too lazy to do that in my head. So that's what the estimate or approximate is for. The estimate is there, whoops. The estimate is there to help you get an answer that's quick and under pressure. Let's try this again on the next example. So again, I'm going to post all these answers on Blackboard. So if anybody's having any technical glitches or any weird stuff going on the first day, right after the lesson, I'm going to post all this stuff, okay? So don't worry if you missed something small. Here's another situation. As a manager, you're sitting in your office and you're like, oh shoot, I got to order 863 units of material at $37.50. That is beautiful, Victor. That's exactly what you want to do. You want to find an answer quick. So a quick estimate is 863 units by $37.50 per unit. That's the exact. And the estimate would be 900. I like how you're saying it, looking at about. The whole point is that you want to be kind of relaxed about it. You know, you want to be a little bit like, exactly, Victor. Don't sell me anything. I don't trust you. I just met you online. You know, I don't buy stuff from people randomly online. So, you know, I don't want to have any issues. I got PayPal protection. Jeez, you should quit jobs, change careers, man. That's a good job. Okay, if you get into like sales tactics and things, then you got to start talking to me about sports cards. I'll tell you about my collection. It's mental, absolutely crazy. Okay, anyway, 900 times 40. 9 times 4 is 36 with a bunch of zeros. Count the zeros, right? 3 zeros. What I want to direct your attention to is the following. I like to write units for numbers because it's a physics class. Okay. Yes, keep one significant digit for each intermediate calculation and for your final answer. So absolutely. I think the answer that I post on Blackboard is 36,000. Just because when I typed it, I think I changed the question after. But 40,000 would be the final answer for this question. Yes, keep one significant digit and for your final answer. By the way, in real life, I wouldn't round the answer. But then again, I took this question from a textbook, so go figure. Okay, now let's get the exact answer. So if someone's got that, please hook me up with an answer there. 32,000-ish. I didn't do that in my head. But you can see here that this answer is pretty close to this answer. And from the thank you, Alakbar. See, the nice thing about this is that in a very short time frame, you can determine if you have enough money in the bank to pay for that particular purchase order, sorry. So that's the purpose of estimating. It's quick calculations. Here's another one. Uh-oh. I think I'm in the middle of a conversation I should get out of. Okay, let's try this one here. By the way, if you don't know what kilowatt hours of electricity is, it's a measure of energy. So when you pay an electricity bill, it tells you on your bill that you used this much energy and the energy costs this many cents per unit of energy. So kilowatt hours is a type of energy or measure of energy. So let's get the exact amount. Thank you. So, yeah, big numbers. 104.06 or $104.06. A couple of comments here. I like writing units, and I encourage you to do the same. Yes. So the interesting thing here is that I'm not really questioning. Um, I'm not questioning the level of accuracy for this question, Victor. This is just the exact answer based on your arithmetic. But let's get to the actual question, which is the important part is here, the estimate. So let's get that estimate on paper. I'm just going to recycle this. One of the advantages of working online is I can do stuff like that. But I promise I'll slow down anyway. So how much is this? Is this 400 or 500? Yeah, $2. I'll take that discount. And this is 20. And 5 times 2 is 10 with 3 zeros extra. So 100 bucks. 100 bucks. But for me, $2. I like your business skills, Paulo. Okay. So 100 bucks. See, that's the nice thing is that you can look at a statement. Let's say this happens. Let's say office and an employee walks in and says, "Sir, our hydro bill is $10,000." And then you look at the bill and buddy screwed up something about a decimal point. You can quickly figure out silly mistakes like that, flagrant mistakes even, by just counting as significant digits, estimating with very few significant digits and ironing out a situation. Yeah, you definitely wanna round up the numbers. You wanna round the numbers up. Most certainly, David. Absolutely. But what I'm saying is that if this is nice also to pick off mistakes in calculations. So if someone comes up to you and says, it's not $100, it's $400, you know that it's really off. Yeah, definitely want to be planning for the worst. That you want to hedge always. I agree with you, Victor and David, absolutely. Or you can take the discount that someone mentioned earlier. The significant part. Okay, what specific in this question? Explaining the significant part in this question or elsewhere? Okay, so in this question it says keep one significant digit in your intermediate calculation. So this 473 is exact. I need to loosen that up a bit, so I'm going to get it to one significant digit, which is 500, because these zeros here are not significant. This 22, I need to make it less significant. So I make it 20, because 20 is only one significant digit, because the 0 does not count as significant. And then I just use those numbers to proceed with the calculation. Sounds good? You're very welcome. Okay. 104.06 is 5 digits, because both zeros are sandwiched. Oh, by the way, thank you, Victor. If someone asks something in the chat and someone else answers it correctly, it's done. I'm not gonna continue on that conversation. So thank you for helping each other, even for the technical annoying stuff that might be the first day. It shows good teamwork. Now, when I wrote these books, there's no way that we're going to cover 70 questions in reality. In the two classes. I always aim a little bit higher in the event that there are more questions directed toward a specific topic. So I'd like you to try some of these on your own as well, because I do give you full solutions. So a nice question to try for homework is 14. So I'm going to skip 14. And we're going to go right into 15 so that we're going to continue with something a little bit different. So now we're going to move on to scientific notation, which I kind of touched on in an earlier conversation in the first hour. So ordinary notation is just what you know as everyday life. But now we're going to figure out how to interpret and use scientific notation. So what you see in scientific notation is very specific. I'd like you to, if you don't have the book, it's fine. I'm going to go back to an earlier page in the theory, right here on one of the earlier pages, page 2. And I want to direct your attention to this box here. Sorry, I'm not going to read the question. I'm going to do this first, that's why. This is scientific notation. Whoops. Like I said, my stylus is really messed up. It's not me. It really is not. It's like there's a delay. Okay. Anyway, the main thing you want to notice is that this number here in front be a number that starts with a 1 up to and including a 9. So that number's got to be between 1 and 10, but it cannot include 10. So scientific notation has that feature. So if I go back to this question, this is a number. See this number here? It's less than 10. Very important. So yeah, the question is to write it in ordinary notation, which just means to expand it out. What is 10 to the 4? How many zeros? How many zeros is it? Yeah, it's 4 zeros. It's 10,000. Good. And then you can expand it. Now, some people will do this. Some people will say move the decimal to the left or move the decimal to the right. I don't care how you say it. What I always tell people that works really, really clean, like I don't say left and right. I say make it bigger because 10,000 is a big number. It's bigger than 1. So I would make this number bigger. So I'd move the decimal in such a way, 4 spots, so that it's bigger. That's it. So we can apply that logic to the additional questions here. So 10 to the negative 3 is 0.001. And now you got to move the decimal in such a way it gets smaller. You can say you move the decimal to the left, or just say make it smaller. So 0.12, that moves it 1 time, that moves it 2 times, and that moves it 3 times. Thanks, Devin. Yeah, you know what? I hate saying left and right. You go to a kid in grade 7 and say, oh yeah, go left and right. They're gonna be back and forth to left and right. If you just say make the number bigger, you can't screw it up. If I say make the number, if I tell you, I'm not trying to get like, I'm not all jacked up right now on energy or anything. If I tell you move the decimal to make the number bigger, you're not going to screw it up because you know what a bigger number looks like. But I haven't taken a sip yet. It's very sad. Thanks for reminding me. I'm very passionate about this stuff, guys, because I see when people say things to people to explain math, and it makes me so angry that they're saying it in such a complicated way. Like it irritates the heck out of me. If you don't believe me, I'm not trying to sell the channel. Watch my YouTube channel of factoring. You'll see what I'm saying. I cut the BS. I'm an engineer. I'm not one of those people that likes to like use big words and show off. I don't give a crap. I'd rather play with my hockey cards. Anyway, okay. Or go for a bike ride or something. Okay, let's keep on going here. Okay. Okay, so 10 to the 2. 10 to the 2 is 100. So what I'm saying is bottom line, make the number bigger. Yes, Ravina. Yes, Ravindra. Make the number bigger. Move the decimal over a couple of times. So 414 and some decimal part. So let's move on to going the other way, which is to write it in scientific notation. So in this case, yes, that is correct, Shazad and Victor. Victor, you got to write a little bit better. You got to go 4 times 10 to the, I think. Okay, so it's okay. I want to break it down like this for you guys, okay? Remember I said in scientific notation, the number that goes in the front has to be between 1 and 10, but not including the 10. So what's a number between 1 and 10? How about 4? And then put some stuff after that. That's how you want to break this down, okay? First, you got to nail what the first digit is. And now, well, 4 times what is 4,000? Tell me, what 4 times what? 4 times what? 4 times 1,000, right? And then make it a power of 10, and you get Victor and Ravinda's answer. So that's 4 times, whoops, wow, like that. If you write the 4.0, the 0 that you wrote is significant, but the number should be 4. This is 1 sig fig. But if you do 4.0 times 10 to the 3, that's 2 sig fig. So I'll answer your question with a question. How many sig figs is this bad boy up here? The 4,000. How many sig figs? Yeah. So I answered your question with a question. Sorry, I hate when people do that. So, but it'll help you learn it better, I guess, right? So that means that this one is no good. Okay? Maybe I'll use green. Green's a little less abrasive on the eyes. You're very welcome. By the way, all of these things about significant digits will not interfere with your ability to write quizzes and tests in this course, because I've already tested out the software. It doesn't care if you write 4 or 4.0. It only cares for a scientific notation question. So it might be like only one spot in the entire test that it matters. So the first thing I want to do here, I got some answers on the chat, but let me just talk about it first before we answer it there. The first thing you want to do is give me a number between 1 and 10. Here we go. 3.41. Good. Victor, very good. But I'm going to put the extra stuff as well. 3.41. And then you have to figure out, is it 0.1 or 0.01? What is it? What goes here? Well, it's 0.1. That makes it correct. And then you can write it as, oops. Yeah, it's going to be negative always because it's a decimal this time.
When we're writing this stuff in the quiz, is it okay? Like, do we have to do it how you do, like the power thing, like the -1, or is it okay if we do it the way we do with like that upwards arrow thing and then the number? Like, will I understand or no?
The actual interface is very clean. It allows you to you'll see when you start to use it. It's really hilarious. It's easy to use.
Oh, okay.
It's like literally click on this picture to make a fraction, or click on that.
Okay, cool.
It's really organic. Okay, you're not.
Okay.
It won't be stressful. And as a footnote to your question, but a little bit more broad, only one part of all of the possible questions I could ask you would be really picky about scientific notation, and that's the section on scientific notation.
Okay.
So if we cover like 50 sections of the book or 40 sections or whatever it is, it's only going to impact one specific section. So
Okay.
you're safe. Cool. So yeah, this guy over here is small too. So whoever was saying negative exponents, yeah, I think you're on point there, Shazad. So the first thing I'm going to do though is I'm going to write this as 2.2. Sorry, whoops. My bad. 2.2, because I need a number between 1 and 10. Then I'm going to figure out what decimal that is. So if you don't, I can't type now. So I'm going to put 0.001 because that'll allow it to move enough places. And then I'll write that part. And if I'm writing too much for you and you just write the answer, power to you. Do that. You don't have to show me baby steps. It's okay. Okay, one more of these. So a number between 1 and 10 is 5.4. Thank you, Victor. Step 1. Step 2 is that it's 10,000. And step 3 is that you replace the 10,000 with a power of 10. And that is how you do that. So the next thing that we're going to discuss briefly is how you use your calculator. So on your calculator, there is a button for scientific notation. So the button on the calculator can look like this. It could be this. It could be exp. It could be EE. Or it could be this button. So those are the ways that you can see it on your calculator. So it's up to you to figure out how to use your calculator. I tried to do the experiment last time about helping people use their calculator for scientific notation, and it ended up being a bit of a heavy problem because everybody had different calculators. So what I did was I said, whoever cannot figure out how to do it on a calculator, stick around at the end of class. There should be a little bit of time at the end, and I'll work with you individually to sort that out. So if you cannot answer this question on your calculator right now, just deal with it at the end, okay? Or you can YouTube it. Yeah, Paulo, exactly. You can YouTube the calculator model as well. So I'm going to answer this question just by, it's more of like, it's like you're getting your driver's license for the calculator. So for this question, the final answer you should get, if you multiply those numbers out, I see some people have already presented something. I got the same answer as you, Shazad. I got 2.77 times 10 to the 4. Now this answer is not you've lost some accuracy, but the question says 3 significant digits right over here. So that's why I have 3 digits over here. You got to keep it consistent. So I am, for the sake of time in mind, I'm not going to dwell on this anymore because I found that it was out of like 35 people, it was only like 4 people or 5 people that had just bought a new calculator or something and they weren't familiar with where to find it. So let me help those people at the end of the class, and let's move on to the next topic. We're going to do about 10 more minutes and then we'll take a break, but I do need to cover this so that we're on pace for the lesson. So this one over here, just try this one on later, okay? It's just another exercise in using the calculator. If you want immediate feedback if you got it right, I'll just tell you the answer, but let's not worry about like why it is. Just get the answer eventually by next class. And if you still can't do it, you can email me and take a picture of your calculator in the email. So the answer that I got was 1.81 times 10 to the 3. Eventually, if you get that, you're in good shape. That'd be like expert level, because you got a square root in there. It's a bit of a mess. So I mentioned to you that there is a quiz next week. So your quiz will be half an hour, and it's going to be like, I haven't decided yet. It could be like 5 to 10 really, really, really short questions, things that you can answer in less than a minute probably. Like this here could be a quiz question. Can you do that in less than a minute? Probably, hopefully. Anyway, your quiz will be 10 questions. The thing is that unfortunately, I got you, Brian, there, and Victor. Unfortunately, I cannot differentiate part marks on easy and hard questions. So what that means is that your quiz might be like 8 questions, let's say, or whatever it is, and they're all worth 1 mark, whether it's easy, medium, or hard. So what I'm saying is, don't screw up the easy ones. So if you get 7 out of 10, and you lost a mark because of the hard question, hey, it was a hard question, no problem. You still got an 88%. But if you got 7 out of 10 and you screwed up the easy question, then next time slow down and don't screw it up. Or just make sure you double check it. Okay. Yeah, because that's the way the quizzes are. And then another nice thing about the MyLab is whatever questions, if you do get something wrong, whatever question you get wrong or questions, it'll tell you what sections they relate to, and then it'll give you remedial help. It'll tell you, try these exercises to get better. So it's going to be like your personal coach. So yeah, it's -1. I'm going to just go through the process here. So x plus 5 equals 4. If you're wondering why am I writing so much, I'm not trying to drag this on too much, but I want to discuss just kind of like algebra with you. So the objective is always to isolate the x. So whatever operation appears here, you need to figure out what the inverse or opposite operation is to undo it. So if you're adding by 5, the opposite would be to subtract 5. But whatever you do to one side, you must do to the other side. Now, when you do that, some people will say, oh, the 5 just magically moved over. And that's fine. So I don't really, whoops, oh no, I crashed. Give me a second. I got to reload. That sucks. I've been saving it though anyway. Gotta love Windows. Okay, so I lost the answer for 23. Yeah, I think I'm running a Mac here. I got a Mac Pro. So yeah, the problem is it's not the Apple. It's actually the fact that it's a Microsoft software, I think, because I rarely have things crash on this computer. That said, watch everything crash now. The problem is, guys, that Kiara, where are you? The problem is that I do a lot of programming. Like I am a pretty hardcore programmer as part of my research and my expertise. Like I'm an expert with algorithms and things like that. Like I'm into artificial intelligence and other things like that. And yeah, coding on a Mac is way easier than coding on a Windows machine. I actually I prefer to code on a Linux machine, but there's no way I'm going to be running any teaching software for the college through a Linux machine, because there's too many issues. Yeah, if you don't know how to use Linux, No, it's not that you're saying that you don't, but Linux is like way harder to use, but it does not break down. Well, it is of opinion, I guess. Oops. Okay, in this case, you want to get rid of the 4. The natural way to get rid of multiplication is division. So divide both sides by 4. Thanks, Ravina. Yeah, that's the right answer. So if you want the answer to 23, you can see Ravina's post. What's E here? -5. Okay, let's take a look at 26. If you don't mind, I am going to go a little bit faster on the next two questions because they're not too bad. The main thing I want you to take from today's lesson is the format. I want you to see how I'm doing things, the pace that we're establishing, and how fast it shows that you need to be able to work for the lesson. In this case, you have a negative and you have a division by 2. So the first step that I would do is this. You can just move the negative to the other side by multiplying by -1. Now, I would do that right away if that's something that you feel like doing. Okay, if you're getting a little bit saturated with the writing, I promise you, I'm gonna go for quality over quantity as the semester goes. Okay, so Kiara, Mario, as the semester goes by, I promise you, it's more quality than quantity. So yeah, it is a bit of a boot camp today, and it might be a bit of a boot camp next week, but not as much probably. We don't write as much. The lessons are less and less writing as the semester goes. Okay, just so you can be good with that. Yeah, I'm posting the PDF. So if you do need that, yeah, oh yeah, if you're copying the question down, hell yeah, that's a lot of writing. Yeah, if you print them, it's a joke because you just have to write your answers. You don't have to copy other stuff down. You're eliminating essentially copying the question down. Yeah, print it out. If you have the chance to print it out, print it out. Ultimately, you're going to be given the digital files anyway. In this case here, we're dividing by 2. Let's move it along though. So the opposite, sorry, we're dividing by 2. The opposite would be to multiply by 2. So for that person that said they weren't sure how to do it, you want to undo division with multiplication. So now those 2's cancel. So you get t equals -10. So you're always asking yourself, what process will undo the other process? So anyway, these earlier questions that we solved, maybe they require 1 or 2 steps, but the ones that are a little bit more involved may require more steps. I'm going to delay the break a little bit so that I can get to a specific milestone in the questions. So we're gonna work through 27 and 28 and 29. Okay, we'll do 27 to 29, and then and we'll probably take a break at that point. So the first step you want to do here is you want to expand the bracket. So you got this. The first thing you want to do is bring the negative into the bracket. So that'd be -x, -2. And the next step is then to move everything that has an x on one side and everything else onto the other. So the first thing that I write is the equal sign. I write the equal sign first. And then I just start playing tennis. Okay, so let's take this x. Does this x move over to the other side? No, it stays put. Does this 2 move over to the other side? Yes, and it becomes positive. Does this 5 move to the other side? Yes, it becomes negative. Does this 5x move over to the other side? Whoops. Yes, and it becomes negative 5x. So it's like you're playing tennis. Just things are bouncing back and forth on the equal sign. And at this point, I saw some people's answers. They look correct. That's negative 6x equals negative 3. And you can divide both sides by negative 6. Yeah, it is. It is, David. It's 3, but when you move it to the other side, it becomes negative. Okay. So you get. Sorry, I went on silent for a second there. I was just sorting that out. Okay. Let's do a couple more. Actually, no, we can take a break. It's fine. Let's take a break till 3 o'clock, okay? More tea time. So someone had a question about their screen was not being full screen. They couldn't see the lesson. Can you remind me, that person? Someone said they couldn't see the screen. Okay, Aiden, there you are, bud. So what's the problem? Can you see anything of my presentation?
Hi, sir. Can you hear me?
I can hear you. Yeah, sorry, 1 second. Ali Akbar, the recording is automatically done. After the lesson's done, it takes about half an hour, and then you'll see a bunch of recording files in the Blackboard Collaborate tab. And it's the same for all your courses that have Blackboard Collaborate. Okay, talk to me, Aiden.
Hi, sir. How are you?
I'm well. How you doing?
I'm good, thank you. So I've
So
been
what's
using
going on?
Blackboard for all my other classes, and there's been no issue. But when I logged on, I don't know if it's because I logged in a few minutes early today. It only shows like an icon, and it says you're speaking, and it says that you're it says Dr. John Gattis is sharing content, but I can't see anything.
Okay, there's different things you can click maybe to change the perspective.
Okay.
Let me unshare my screen.
All right.
Let me share a whiteboard. Do you see the whiteboard?
No, I don't see anything. It just shows your icon still. But it doesn't say you're sharing content anymore.
Okay.
Okay, now the whiteboard just came up.
Okay, now I'm sharing something else.
Nothing.
But you
I
saw
don't
the
understand
whiteboard.
though. Yeah, I saw the whiteboard. It was a little delayed, but it came up.
Okay. I'm not sure what to do because there's.
Yeah, I don't blame you, sir. Me either. Like, it doesn't make any sense though because the same program was working fine for my other classes. Like, I was able to see whatever the professors were sharing, the content. So I don't understand why this is not showing up because like I've logged in, logged out, I reset my computer, did everything, and still nothing.
I'm gonna leave the classroom. I'm gonna unshare whatever I'm sharing. Let me just leave and come back in.
Okay.
Okay, I'm just gonna turn off this recording stuff. Okay, 28. I don't know the answer off the top of my head, but I think that's good. First step here, cross multiply. So what I'm doing here is I'm multiplying I think Aiden's back. Okay. So what I'm doing is the x and the 2 and the 3 and the 5. And then you can get rid of the 2 by dividing both sides by 2 to get 15 over 2, or you can put 7.5. It's fine. What's the f for? I'm not sure. Can you explain the f? Oh, beautiful. Okay. Thank you. I'm usually up to my language stuff, but the f, I lost it. Usually, so when I write this, it's not very polite, right? Fine or fine. Hilarious. Okay. Okay. Yes, to pay respect. I appreciate that. Many blessings to you. Okay. So the reason I'm doing this question is over here. What if you had this question? Does this question have the same answer? Yeah, it's the same thing. So I want to point out a very valuable thing. Yeah, it's still the same answer. See, if you cross multiply, the 2 and the x still stick together, and the 5 and the 3 still stick together and become 15. So the lesson I want you to take away from this is that when you see fractions with variables, it's very much like a highway, diagonally. What I mean is that you can move information this way or this way, and you can switch things around that way. So for example, you see here this question, I can take the x and the 5, and I can switch them, and it's the same question. And I can take the 7 and the 3, and I can stick them together and make it 21. So I can answer the question without writing a single intermediate step. But I'll answer the question in a more orthodox way, which is just to do 5x equals 21, and then x equals 21 over 5. Yeah, 4.2. All good. All right. Okay, for the sake of time, you can try this one with decimals in a similar way. I will leave that one for you to try as an exercise. So 30 and 31, you can try those on your own. But 32 we'll do together. And I will go slowly with this one. Okay, so I've just copied the question down. Now, you might recall back in the day, you might recall that thing. What does the B stand for? What's B stand for? Brackets. Very good. So what you want to do is kind of apply the rules of BEDMAS in a similar way here. So you want to get rid of the brackets, and we can do that by distributing. Over here, 210 times 3 is 630. And this bracket over here, we need to expand that. We need to distribute. So you need to multiply 38.5 times that and times that. So let's do that carefully. So 38.5 times 8.25. I've written this one out so I don't waste too much time on I don't like using my calculator in front of you. Yeah, 0.46 is the right answer. Thank you, Ravina. So you get that. Now it's a matter of collecting like terms. So what you want to do now is move any term that has a D to the left. So let's move this guy over. So I'm going to cut it out and paste it. I'm going to move this guy over. I'm going to cut it out and paste it. But remember, the sign changes to positive. And now you have a bunch of terms that have a D variable. So you can collect those terms into one term. I'm going to continue over here. So I get 690. Thank you very much, Mario. Equals, and you can divide both sides by 690.2. You get a final answer of 0.460 meters. Notice that I did two things here. In your final answer, units and significant digits. Pay attention to those. Whoops, that's my stylus. I'm telling you, it's a little sluggish. When I do these meetings on Zoom, it's much better. Yeah, Victor, you want to go to 0.460 because the question says 3 significant digits, okay? Cool. All right. I don't know about you guys. I'm sick and tired of numbers. I don't want to deal with numbers anymore. I'm pissed off. Just kidding. Let's deal with some variables. Just variables now, okay? No more numbers. So take your calculator and just throw it away. Not literally. Just put it aside. Because the beautiful thing about the remaining questions, it's all variables. You cannot screw up the arithmetic. You don't have to pick up your calculator. It's just scrambling variables. Victor, you're a champ. Okay. All right. What are we trying to solve for here? Yeah, you want to solve for m. Okay. So the first thing I'm going to do is write it backwards because I like to have the m on the left side. And then what I want to do is figure out what operation is going to get rid of the a because the a is bothering me. Yeah, that's the right answer. It is f over a. I want you to say this, okay? I want to solve for m. I want this. So how do I get rid of the a? So I need to get rid of this a. Is that a multiplying the m, dividing with the m, adding or subtracting? It's okay, sorry. I'm sorry, let me rephrase the question, okay? M and a. Is that add, subtract, multiply, or divide right here? Are these add, subtract, multiply, or divide? Multiply. Okay, good. And what's the opposite of multiply? What you guys were saying, divide. So that's how that works, okay? Someone was asking how that works. So I was just breaking it down into a smaller step for someone else that was asking. So then you have the answer, m equals f over a. Because the a's cancel. All right. Let's try this one. I'm not going to copy the question this time because it takes up space. You want to solve for G1. So the first thing I do is I write the equal sign. And then what I'm going to do is I'm going to move these terms over if necessary. I want G1 on the left. That answer is good, Ravindra, but you got to write it as a formula, okay? So you want to say G1 equals what you said. So move the G1 over. You have G2, and then RL, you don't want it over here because you want G1 on the left. So you're going to move RL to the other side, and it becomes negative. I stay with that. Perfect. So you see, these questions don't necessarily take a lot of steps. It's just nice to see them in what they are, shuffling around a bunch of variables. And if you follow the basic rules, it's not too bad. These formulas are also not just some random formulas that I want to throw at you or something. These are formulas that are coming from construction and or management. So they're useful. They're things that you might encounter. The purpose of the exercise with writing these formulas and rearranging them is so that when you encounter a formula in the future and you need to rearrange it to get some other information, you're not intimidated by the algebra. So you want to start with the G1 to the left. Yeah, you have to switch the sign. That's right. Yeah, Victor. Yeah, so the first thing that I always write down, you'll see here, is if I'm moving things around left and right, the first thing I do is I try to write the equal sign. Let's go through this question together. This time I'm going to copy the question. So there's a question. This question is actually a fraction equation or a rational equation. So the first thing I'm going to do is write it as t over 1, because we understand that there's a 1 underneath. The 1 is understood to be underneath. And then the next thing is you can cross multiply. So I'm going to take my time with this one. Sorry, I'm not really following the chat now with your proposed answers for a second. But the first two steps, it takes you to a place that looks like question 34. Now you're just moving things left and right. So what you can do in the next step is you can, I'll just copy it down again. You can move things around so that b is by itself. So the first thing I'll do is write the equal sign. And I'm going to do this. TV, I'm going to move the c over and have just d by itself. That answer is correct. Now you might be like, oh, but isn't the d on the wrong side? Well, it's an equation, right? Whether it's on the left or the right, it is isolated. If that bothers anybody, that's okay. We can fix it by just writing the equation backwards. So here, whoops. Could you divide the t1 by v? I cross multiplied. What I did here, Victor, was I cross multiplied. I did t times v, and then I did 1 times that, all of it. Cool. Yeah, this stylus thing is a little bit irritating. If I was using Zoom for the lesson, there's no delays, but it has to do with Blackboard. It really is a pig on my RAM. So you move the denominator to the one side of the equation. Pretty much, yeah, because you're multiplying, you're moving it, you're sticking them together like when you put them like this together, it's multiplying. So when you say move, you're moving them together, but the way they're connected is multiplication. Okay, I think you have it in you for a few more, and then I can answer some calculator questions or whatever else you might have to ask me. This type of equation comes from physics, specifically mechanics or forces, I'm not going to ask you to develop equations like this, but I will tell you, in the second semester, halfway through the second semester, the course becomes physics. So I teach you a whole bunch of stuff from physics that's going to help you prepare for your second year. So yeah, it's going to be interesting, but I promise you that I'm going to teach it as if you've never seen physics before. Just like when I teach you the material for this course, especially the calculus component, I'm going to teach it as if you've never seen calculus before. So I'm not teaching it to the top student, I'm teaching it to the bottom student, or somewhere toward the lower half too. I don't want to leave anybody behind in this process. So you're welcome. So yeah, if it gets a little bit slow for you, just work ahead. But I promise you, whatever I teach you, I'm going to throw a spin in there that you didn't see in high school, or at least most of you have not seen in high school, because I want you to think of it on a higher level. I don't know about you, but I see fractions. And the minute I see fractions, my instinct is to get rid of them as soon as possible. So my first instinct is to cross multiply. So in regard to this question, it's very similar to the previous one. Okay? So let's cross multiply there. So we want to solve for big M. So I'm going to put big M like this. Yeah, that's right, Victor. But make sure you write a capital M for the first one, because I was confused. I'm not that picky. It's just this question's picky. So the next thing you want to do, it's kind of built on the skills that we were using earlier. You need to get rid of the brackets. So let's distribute the A. So A times big M is AM. That's right. That's right. And then 2MA. And then it's time to play tennis, because we're just going to make things hop left and right. So anything that's not a big M has to go to the other side. So this guy over here, he's got to go. He's going to go over here. And he's going to become negative. We're almost done the question. That's good news. I think you are correct. So you want to get rid of the A, because if you get rid of the A, that will sort out the issue. And I like, Ravina, that you put the brackets, because that makes it correct. I'm going to divide this side by A, and whatever you do to one side, you got to do to the other side. So you see how I have the brackets like you do? Then even the equation editor interprets it correctly. And then you're done. And that is that. Whoops. Thank you, Victor. I'm gonna do the last two questions, and then I'm gonna show you. And then I'm gonna whoever is feeling good and they can go. One of the A's cancel out right here, or over. Do you think these A's cancel? These ones here? Nicholas. Yeah, these A's don't cancel. Whoops. These A's right here do not cancel, because this whole thing is divided by A. So in order for A to cancel, they both have to have an A. They don't both have an A on top. If they both had an A on top, yes, then the A's would reduce. But because only one term has an A, then they don't. Cancellation only occurs with if this is multiplied. If this was multiplication, yes, the A's cancel, but it's subtraction. So that means you have two unique terms, and you cannot do that. All right, we're trying to solve for y1 in the next question. I'm gonna just go through the first step before I see any comments. First step you want to do is expand, or you can try another thing here as well. So I'm going to do this question as economically as possible. See, the thing is, you want to get y1. So what I'm going to do is work from the outside in. I'm going to try to get rid of the d and the g first because they're on the outside of the bracket. I'm going to divide both sides by dg. And if you do that, then the dg's cancel. So now it's a lot more manageable. Okay, so now you want to solve for y1. So what you can do is, again, kind of use the analogy of moving things left and right. So you can take the y1 and bring it over here. And you can take this term and move it over there. This answer is correct. However, for some people that are interested, you could actually, yeah, this is a final answer. Some people, like me, for example, don't like the fact that there's two negative signs. You could simplify this further, but it's optional. So if you go to my solution on Blackboard, eventually when I post it later today, you'll see how I simplified this a little bit further. But that answer is good. Let's do one more question together, and then we will stop for today. So normally our classes will not go this long, like in terms of the lessons. I prefer the more simplified answer, but I would give full credit to this answer. And in terms of the computer, like the MyLab, when you type something like this in, I think it'll be very forgiving about your answer, or it should be very forgiving. If it isn't, you can take a screenshot and tell me about it, and I can fine tune things like that. So let's say that you had a quiz and something happened on one of the questions, and you're like, no, I think I was right. Take a screenshot of it and email me it and say it said it was wrong, and then I'll look at it and I'll see if it was wrong or not. And if it wasn't, I'll give you the mark. But those kind of things I'm not too worried about, because I don't plan on making the quizzes some crazy questions that are like 10 steps and all complicated looking. They're going to be short and sweet. Okay, last question. This guy over here. So I'm just going to copy it down and then we'll talk about it. Yeah, the questions are in the outline. Yeah, the one that I had in color that was in yellow and green, you do the ones that are in yellow, the ones that are for today. So the first thing you want to do, in the same spirit as the previous question, is cross multiply, because it's easier to manage without the fractions. So let's cross multiply here. So we can do like 3. I hear someone's microphone on. Can you mute it for a second, please? I'm not sure who it is. Okay. So we want to solve for L. There's other terms here that do not contain an L. So the first step would be to move that term over, this guy over here, since it does not possess an L. And it'll become positive. For those that are not sure what happened on the first step, on the first step here is you want to multiply that and you want to multiply that. I think I heard a door moving. I think Ayomid maybe left the room for a second. They don't know that they're on the mic. It's okay. Anyway, here, that's the cross multiplication. So see, 1 times all of this is just all of that. That's why you see the same expression right here. Because it's being multiplied by 1. So it just is the same thing. Now, the interesting thing, and really the last step of this question, is to get rid of the stuff on the left. You need to get rid of whatever here, whatever is not an L. So what part of this is not an L? Well, that's rhetorical. I know the answer, and so do you. The 3, the p, and the x squared. Thank you, Victor. So that's what I'm going to do. I'm going to divide both sides by that. And then I'm going to cross my fingers. Just kidding. We got this. We got this. We are smart. The 3's are gone. The p's are gone. The x squareds are gone. And the only thing that survives is the L. Thank you. Checkmate. Checkmate. You sunk my battleship. That's enough. We got it. So anyway, that's enough of the lesson. I promised I will convert this to PDF, and I'll have it online for you as soon as I finish with any questions that people might have. But as far as you're concerned, the lesson's done today. Yes, you can write the answer a different way, Ravindra. Yes, yes, yes. Your answer is also correct. I'm not going to leave it like that. Okay, but that's okay. So let me do a couple things here before I forget. I'm going to quit the recording.